Welcome to Topic C, which is use equations and inequalities to solve geometry problems. That is our newest topic in Module 3. This lesson we are about to embark upon is the most famous ratio of all. And it's not Rudolph. But anyway, yeah, so get ready for some fun with a very famous ratio. Okay, one thing just to know beforehand is that we are going to be creating circles in this lesson. And I'm trying to make a circle here. Got my circle tool. I thought I had my circle tool. There we go. Woo, okay. So we're going to be making lots of circles in this lesson. So if you could right now or before we begin, go out and make sure you have a compass. Now a compass in the sense of a circle making compass. You know, it looks something like this. It's usually got like maybe a pencil on this end, and then it's got a another part up here, and then it's got a little pointy sharp pin right here, and then you just you stick it down, and then you move it around, something like that. Or there are other things that we have actually in the annex, something like this that has these different size circles that are pre-made in there, and then you just trace that circle. You know, a compass is real good because it does give you a real wide range of size circles that you can make. Okay, so we want to get to make as perfect circles as we can. That'll be really important. Okay, so yeah, before you continue here, go ahead and make sure you have a compass first, and also a ruler or some straight edge ruler would be preferable. Okay, so in this lesson we're going to learn a lot about circles and define different parts of circles, and talk about relationships in a circle, the different measurements, different dimensions of a circle, and how those different measurements and dimensions, how they relate to each other, okay, relate to one another. And we're going to talk a bit about ratio, okay, ratio when it comes down to this. But if we would do this, first thing to do is go ahead using a compass, okay, or some other circle making tool. Go ahead and draw a circle like this to the right, this one right here, okay. Go ahead and draw that right in your in the middle there, in the center, okay. And just some couple things to notice, you know, that there will be different ways we will see circles labeled, okay. And C is generally going to be the center, okay. So the center of a circle, all right. That's C, okay. That's the center, all right. And then the distance between C and B, in this case here. This distance is known as, and I think most of you do know this already, but it's known as the radius, okay? Known as the radius. And those two things are also mentioned right down there, okay? So just take a moment and go ahead and do letter B here. It says, write your own definition for the term circle. If you were going to put it into words, how would you define the term circle? And go ahead and take a few minutes to do that. Come on back. So you might have, when it came to your definition of circle, you might have said something like round. You might have said something like curved. Okay, use those. Oh, I'm sorry, I had you continue. I had my thing continue. I thought I was actually had turned it off. Well, here's what I wanted you to do then. I'm so sorry, what a waste of your time. Is to go ahead and draw another line segment that is going to look like this. So you're going to have now 2 points of radius here, 2 radii. Okay, so you have a radius CB, and you have the radius CA or AC. Okay, so the question here is, and this is what I wanted you to do. That's this part right here. Okay, so you got CB and then segment AB. Now, okay, we want to compare. So here's what they want you to do. So the length, in this case, this is always going to be true. The length of segment AB is called the diameter. Okay, now we have a new term, and again, these are terms. You know, diameter, radius. I know that you understand already, but yeah, diameter is that full length, that full segment across a circle, face of a circle. Okay. Now the diameter is always twice as long as radius. Okay, so the diameter is always twice as long as the radius. Okay, on a circle, every single time, every line of diameter you draw, and again, it needs to be drawn correctly. I'm not sure exactly how correctly I drew that diameter. Okay, a good way to draw a diameter exactly in the center of a circle is if you cut out a circle, or if you have it and you fold it in half and then fold it in half again, you have that point in the middle, which is your perfect center. But when you use a compass, really nice, your perfect center is going to be the little hole that you create with your little pin point. Okay. All right. Yeah. So the point there is what we wanted to make is that the diameter is always going to be twice as long as the radius. Okay, and that's one relationship. Okay, in this part of this exercise, we're going to go ahead and see how accurate these reproductions are. Oof, I sure hope they are somewhat accurate. So go ahead and take your ruler, okay, and let's make it metric. Let's do everything metrically. Okay, so I want you to go ahead and measure the radius and the diameter of each circle. Okay, of each circle. And you can see the center is labeled C. All right, so you know where to measure from when you're measuring your diameter. Okay, so again, measure the diameter and the radius of each circle, and let's go ahead and come on back and see if you get the same measurements as I did. Okay, so if you did that, you probably, well, hopefully you came up with some of these measurements, or maybe somewhat close, but the main point is, in every case, a line of radius should be half that of the line of diameter. Okay, and you can see that happens in all of these. Okay, radius here of this larger circle is 3 centimeters. That would be from here to here, and then the diameter would be 6 centimeters, which would, of course, cover the entire, would go right across the face of the circle. Okay, so you may have gotten those exact dimensions. If not, the major point is that every time, in every case, your diameter was twice that of your radius. Okay. Okay, and even though I can't see it, I'd like you to go ahead and try this. It's good to practice using these compasses. And if you would go ahead, your task right now is to go ahead and draw a circle with a radius of 6 centimeters. Okay, so go ahead and grapple with that. It may not be as easy as you think, and come on back, and I'll give you some tips if you had any difficulty with it. So I'm not sure if you did have to grapple with that, but one way you might have started, if you did have some difficulty or you're still having some difficulty, is to, using your compass to have made a dot, maybe. So here's where your compass is going to spike. Your spike's going to be right there, okay? Go ahead and measure those 6 centimeters, okay? And again, this is not drawn to scale. And put another dot down, okay? So because you are trying to create a radius of 6 centimeters, therefore, the spike here is actually going to be your center, okay? That's where the spike is. That's the spike on your compass, all right? So one of the better ways would be to take that spike point, stick it in, or make the little hole there. Go ahead and measure the 6 centimeters from it. Put down another dot, and then you put your spike in, and then the pencil down, and then go ahead and draw your circle. Because this is terrible job I just did. But using the compass, if you have designated that 6 centimeters right there, then you can go ahead and draw your perfect circle, which would look a lot more perfect if it looked like this one over here. Okay, so again, just getting used to making those. You might have done it a different way. Yeah, but that would be probably your best way. Now, in this case, the diameter. Some of you may have just done it with diameter. You may have just made a circle that was actually 6 centimeters in diameter, instead of paying attention to the fact that it was the radius you were looking to make as 6 centimeters. The diameter in this case is, of course, 12 centimeters. Okay, so I was trying to figure out a way to do this activity on video and then post it here onto the presentation, like a video within a video, and couldn't figure it out. So I just took a series of photos here. Anyway, there's this exercise or this activity. It's called mathematical modeling exercise that you might see in your. I think you see it in your binder there. But anyway, the whole idea is for me, the teacher, to have something round, a round object, like a wheel, a bicycle wheel, or in this case, I have a hubcap. Okay, a hubcap. I bought 4 of these for my son's car, and they don't fit. So if you want one or more of these, just let me know. No, serious. But anyway, yeah. So here's this hubcap, and it is it has a few measurements here. As you can see, we can measure its diameter. We can measure a line of radius, and then the one thing we want to talk about, we're going to talk about right now, is this circumference. Okay, the circumference is that measurement around a circle. Okay, and we're going to talk about the relationships, and these relationships. Actually, one relationship in particular is what we call the most famous ratio of all. Okay, and I think you might recognize it soon enough as pi. But let's go ahead and take a look at a little more closely at this hubcap. Now, to measure the circumference of this hubcap, I mean, we could take some yarn or some string and just string it around there. It's real difficult because what happens very often is that it slips off. It's not real precise. It's hard to do one person. But one way that's particularly good and very, very accurate as well, okay, is to pick a point, as I have right here on the round object, whatever it is. And I really, really, really highly recommend that you go ahead and do this at home with any round object you may have in the house. Okay, this whole exercise, this whole activity, it is a lot of fun, and it really does bring up a real aha moment. Those aha moments, like, wow, I can't believe that. But anyway, yeah, so pick a point on that, on the round object, in this case my hubcap. And what I've done is I put a little Post-it note here, a little Post-it note arrow, and I've also on the floor here, because this is really messy and dirty, and my wife would be very angry at me if I made a huge mess of the place, I put a little dot on a paper towel. Okay, as you can see, a little red dot right there. Okay, so what I'm going to do now is I am going to, or I already did, but what I'm going to do is I'm going to actually complete a full rotation of this hubcap by rolling it this way. Okay, I'm going to roll it along this paper towel. Okay, and you can see there I am rolling, and I rolled it all the way, and I rolled it until you can't see it here actually, but the little paper, the little post-it note arrow is now down, pointing at the Scott towel once again. Okay, so I've gone from the beginning here, and I've rolled it this way until the little arrow, that post-it note arrow, is there again. Okay, and as you see, that is one huge distance. Okay, from there to there, one rotation from here around that hubcap, one rotation is that wide. Quite amazing. Okay, and it is really, if you do this at home, even like just a top, if you guys use Quaker Quick Oats, and you know one of the tops to the oats, if you take one of those off and you go ahead and do this little rolling activity, this rotation activity, you'd be amazed at that distance that you get when you look at it in one dimension. Okay, one dimension. And again, another thing you can do, and here's the part of the relationship we're talking about, because what I've done here in this picture is I've laid out this, the hubcap in terms of its diameters here. So I'm doing a line of diameter right there, and what I've done is here's the beginning of where I started my rotation. Okay, from rolling the the hubcap one full rotation. So here is one measure of diameter. I move it down again. Here is the second measure of diameter. So now you can see I've actually, the circumference is now 2 measures of diameter, and then I've laid it down again for a third measure of diameter. And you'll see it's a full 3 diameters and then a teeny bit right here. Okay, and you can see that teeny bit right there. Okay, now you can look at it all together. You can see here is my my hubcap right here, and then you can see my line, this distance that represents the circumference. Okay, it goes all the way from there to there. Quite amazing, huh, when you compare those two. Now, if you do actually do the math here, I bet you know what you'll come up with, because a lot of you know this number. Okay, because again, you see you have, this is like 3 diameters. Okay, and then this actually is actually, gosh, what did I come up with? I think it was 3. Oh, in terms of, no, hold on a second. I'm sorry. I'm thinking about in terms of centimeters. Okay, but yes, so 3 diameters, and we say a little bit. Just for now, we'll use that little bit. Okay, but if you do the measuring, this whole measurement from there to there came out to be 100. Let me use my different color here. 122 centimeters. Okay, 122 centimeters from there to there. So that equals my circumference. Okay, so my circumference of this here hubcap is 122 centimeters. All right. Now the diameter, okay, which you can see already drawn there in yellow, this diameter line, actually I measured it, and I tried to be as precise as I could using centimeters and millimeters, was actually 38.8 centimeters. Okay, and this is my diameter. All right. Now you can see, and you probably know or have a good idea of what my ratio is going to be, but the ratio I am going to try to find is I want to divide my circumference circumference divided by my diameter. Okay, and this is, when this was discovered, it was actually a very magical thing. Okay, magical thing, the discovery of pi, and the circumference to diameter. Also, you could write it as a ratio, and that is a ratio there as well, or circumference to diameter. All right, okay. Yeah, we're actually creating a ratio here. If you did that and you divided 122 divided by 38.8, you would get, and I did this already on my calculator here, I got 3.144329. Okay, now that's what I got on mine. Okay, this is not precise, but if you do, and you are a fan of pi or knowledgeable about pi, you'll know these first 3 digits here are what we are really interested in. When we round off pi, because pi is actually a number, some of you may know this, that is a never-ending decimal. Okay, pi goes on pretty much forever and ever. Okay, and there are some people who actually have, I don't know, they've memorized the first many decimal points or decimals of pi, but we usually round it, and we always do round it actually, to 3.14. Okay, which means that for every measure of diameter, you have 3.14 times that measure in circumference. Okay, so you can get any diameter at all. So let's just go to a new page here. If we had a diameter of 3 centimeters, that was our diameter equal 3 centimeters, we would just go ahead and multiply 3 times 3.14. Okay, and I'll just do that real quickly here, even though I could probably do it even more quickly on that paper. And that's 9.42 centimeters would be my circumference, would equal that. Okay, so I can do that, and I can do that really quickly, very, very easy. Can you imagine now how easy it is to measure the circumference of this hubcap? All I would have needed to have done is measured my diameter, 38.8 centimeters, and then multiplied it by 3.14, which is known as pi. Okay, pi is not only known as 3.14. Okay, it's also known as 22 over 7. Okay, because if you do go ahead and divide 22 divided by 7, you get 3.14285, blah 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 blah. Okay, so we can look, if we're going to use pi in equations and inequalities, we might prefer to use the fraction version. Okay, so I'd like you to write that down somewhere. I'm not even sure. I'm not sure if they may even have it in your binder at some point. But if you would write these down as pi is equal to either 3.14 or 22 over 7, and we'll use either one of these depending on the context of the problem. Okay, well, I guess I hadn't gone far enough ahead in your binder here to see, or I probably did, but I don't remember. But I guess pretty much everything they're telling you here, this mathematical modeling exercise page there, is exactly what I just said. And you can see the and here's your definitions here. So the ratio of the circumference to its diameter is always the same for any circle. What an amazing, fascinating thing, I think. Maybe not as fascinating yet for you, but it will be one day. Okay, so the value of this ratio, circumference over diameter, is called by the number pi, and is represented by that symbol right there. That is a Greek letter, the letter pi. Okay, and you can see what they're doing right here. They're just showing you if you wrapped a string around a wheel of some sort, you'd get 1, 2, 3, and then a little bit in terms of diameter would match the circumference of that that circle wheel or whatever. Okay, and again, this is all pretty much what I said to you already. But since the circumference is a little greater than 3 times the diameter, pi is a number that is a little greater than 3. And pi is, here we go, is non-terminating. That's just what I said. It goes on and on and on forever. Non-repeating decimal, and mathematicians use the symbol pi, or approximate representation, as a more convenient way to represent pi, which we just mentioned. I just mentioned to you 3.14, or 22 over 7. Okay? Now the ratios of the circumference to the diameter and n, or pi, to 1 are equal. Okay? Circumference of a circle equals pi times the diameter. Okay? Everything I just told you was in your binder there. Okay. All right, so here, exercise 2, I'd like you to go ahead and do these. Of course, these are not drawn to scale like they had to tell you. Okay, that does not look at all like 21 centimeters. All right, not drawn to scale. So what I want you to do here is go ahead and find the circumference of each circle, and go ahead and use 22 over 7 as an approximation. Okay, so come on back and let's check. Actually, why don't you go ahead and do A, B, and C. Okay, so go ahead and do that and come on back. Okay, so here we are back. In this A, they asked you to use 22.7 as an approximation for n. I guess they probably did that just because it was all the answers came out evenly, which was wonderful. Thank you to them. Okay, so as you can see for the first one, it was 21 over 1. Okay, we're 21 centimeters times 22 over 7, and that what I did is just multiplied 21 by 22, and actually let me do that again. 21 times 22, and that was 462, and so 462 over 7, okay, because I just multiplied. And when I divided, then all I had to do was divide 462 by 7, and I ended up with 66. So 66 centimeters was the circumference of this circle. Okay. This one, same thing. I just, and again, remember centimeters. But please, all your answers, please put your units in. And here, again, it was 91, and so I just multiplied 91 over 1 times 22 over 7. And did all that and ended up with 286 feet. This one was a little bit trickier. You might have gotten tricked, but they are not showing you a line of diameter here. They're showing you a line of radius. So if you had to go ahead and multiply that by 2, and that would have that would have given you 71 meters. 71 meters. And if you multiply that 71 meters by 22 over 7, you would have come up with 110 meters as the circumference of that circle. All these not drawn to scale. Please do remember your units in any answers that you put. Okay? All right, now with B, they asked you to go ahead and use 3.14 as an approximation for n. Okay? Now, they start off with just telling you that the radius of a paper plate is 11.7 centimeters. This example is similar to this one here, where you're given a radius. So in this first step here, I had to do 2 times 11.7, which gave me 23.4, which was my diameter. Now that I have my diameter, I can go ahead and multiply that by 3.14 and end up with 73.5. Okay, 73.5, because they asked me to to get my circumference to the nearest tenth. Okay, and that's my tenths place there. And again, of course, I used my units, which was centimeters. Okay? All right. Now, The next one was C. A little bit different here. They kind of changed it up. Same radius of the plate is 11.7. Find the circumference of the nearest hundredth. That was one change. But they also asked you to go ahead and use the N button on your calculator. Now, I'm not sure who had a calculator or who was using a calculator that had an N button, but let me show you what I have on my cell phone. Okay, I'm not sure which calculator you've downloaded on your cell phone. I have an iPhone, and as you can see, this one, if you hold it vertically, it's a very simple calculator, but when you hold it horizontally, like I have a horizontal orientation here, you can see that I have many more buttons. And here you see is my pi button. Okay, it's right there. So what I did is I went ahead and just punched in my numbers. What it was, 23.4 times pi. Okay, I didn't punch in. I did 23.4, which was the diameter, and then I hit the multiply button, and then I just hit my pi button right there. Okay, and what it does is it'll show you it'll show you pi to as many digits as will be held on the screen. I mean, if you had a calculator that held 100 digits on its screen, they would all be filled with numbers because, like I said, pi is non-terminating. It's an infinite decimal number. Okay, alrighty. Oh, and I just stay right here. As you can see, my answer was 73.51 because you were asked this time to round to the nearest hundredth. Okay, so here's another one. Here's D. Okay, and D says a circle has a radius of r centimeters. Ooh, this is sounding interesting because now we are talking about our equations. And a circumference of c centimeters. Write a formula. Okay, you're going to write a formula that expresses the value of c in terms of r and okay, radius of r centimeters and a circumference of c centimeters. Write a formula that expresses the value of c in terms of r, right there, and pi, of course. Okay? So go ahead and give that a whirl and come on back and let's see what you got. Okay, well, here are few different ways we could have we could have written this formula, and again that expresses the value of c in terms of r and pi. So we're going to have c equals, okay, in both cases. So c equals pi times 2r, okay, 2r, because pi equals, pi times 2r, because 2r, of course, is diameter, okay, and we know that the circumference is pi times diameter. So in terms of radius, we would need to have 2r, because 2r is going to equal diameter. And we could have also written it as c, circumference equals 2 times pi times r, all right? And you can see why, because we are not, we can commute and use the commutative property in multiplication. So we could, all we did is we took this and moved it over there, pretty much the 2. So all of those multiplied times each other, both of these formulas would yield you the exact same answer. Okay, so E is, it says the figure below is in the shape of a semicircle. A semicircle is an arc that is half a circle, therefore semicircle. Okay, find the perimeter of the shape. Okay, and remember what perimeter is. Perimeter is this all the way around. It is a one-dimensional measure. Okay, so there's well, I won't tell you what. We'll see what you do with it. But once again, perimeter, you're going to find out the perimeter, the very ugly perimeter I drew. But yeah, you're going to find out the measure of that, okay? Of that all the way. A little ant is walking around. How far will that little ant walk? Okay, so go ahead and use what you have here to help you out. And of course, they're telling you that use 3.14 for pi. So you know you're going to have to use pi. Use your brain. Use your pi. Don't eat the pie. Just use the pie and come up with an answer. And let's see what you get. Okay, it's this kind of problem that I really, really love. And hopefully you will love. I love them because they're challenging and they get you to really think and it's just so exciting. So I hope there are going to be many of you out there who are very excited after we finish correcting this. So I just wrote down what we knew. What we know is that 8 meters is the diameter, and there it is right there. Okay, so this thing is actually, I mean, it has a semicircle. So you have to imagine though that it's part of a circle. Okay, that we could draw like that. Okay, so we know that the 8 meters is the diameter there. And we also have this under our belts because we know that circumference is diameter times pi. Okay, so while we know, let me just get rid of this for the meantime because I might mess this up. What we know here is we know we have 8 meters already, this line, okay, line of perimeter. We know this portion of it. What we don't know is we don't know this part here. We don't know this part of the equation, okay, this part of the perimeter, right? Now to find that perimeter, that is just half the circumference of the entire circle. So all we need to do, therefore, is to find out the whole circumference, okay, and that's going to be 8 times 3.14 because that is the diameter times pi, okay, and that comes out to be 25.12. That's not quite helpful yet because that would be the size of the entire circle's circumference, okay, but we don't have that entire circle. We only have half of it. Therefore, we are going to cut that in half. We're going to come up with 12.56. Okay, so now we know that this right here is 12.56 meters from here to there, okay, 12.56 meters. So we have our 8 meters here, 12.56 meters there. All we need to do now is add those two together, and we get 20.56 meters as the perimeter of that semicircle. Some fun, huh? Okay, we can close here with a little relevant vocabulary. Circle, again, seems like the easiest definition in the world, but given a point C, we can see how complicated we can make it. Given a point C in the plane and a number r is greater than 0, the circle with center C and radius r is the set of all points in the plane that are distance r from the point C. Wow, that's pretty heavy, huh? Don't you think? Well, anyway, let's just go ahead and so if we make this circle, make a circle right there. What they're saying, let's go over this a little bit by a time. Given a point C, here we go, point C, that's the center. Sorry, I'm making a mess of that one. The center in a plane, and a plane, of course, is any two-dimensional place. Okay, this is a plane of sorts, right? And a number that is r is greater than 0. Okay, this has got to be the case here. We can't talk about negative numbers here. The circle with the center C and radius r, there's C, there's r, okay, is the set of all points in the plane that are distance r from the point C. So all of, let me go ahead and make that a different color. All of these points here, all of these points, I mean there are several, I mean there are, well I don't know, I mean, it's finite, yes, but which means it has an end, but it's just so many, we can't count these, okay? But all the points on that And that line right there, that circle right there, all this, a set of all those points that are all this distance r from the center. Okay, so you can see how we can take a very simple object, which is a circle, and give it a very complicated definition. Okay, now here's radius. Let's see. This is not going to be that hard. So radius of a circle is the length of any segment whose endpoints are at the center of the circle and a point that lies on the circle. Okay, a little bit more simple. That's right here. It's a line of radius. It's a segment, okay, which means it ends. It's an end here at C, and it has an end. Let's just call that A over there, okay? And all of these are lines of radius, okay? All of those, all right? And they're all equal. So diameter of a circle is the length of any segment that passes through the center of a circle whose endpoints lie on the circle. If r is the radius of a circle, then the diameter is 2r. Diameter is 2r. That's right. And of course a line of diameter, let me get a different color here. This is a line of diameter right there. It goes fully across across a circle, must pass through the center C. This is a line that goes across a circle but does not pass through center C. It has another name. We'll probably talk about that later on, but what it is not is a line of diameter. Okay? To give us a little definition here, the word diameter can also mean the segment itself. Context determines how the term is being used. So right down here it says the diameter usually refers to the length of the segment, while a diameter usually refers to a segment. Similarly, a radius can refer to a segment from the center of a circle to a point on the circle. So, like I've been using the term, I'd rather say a line of diameter. Okay, you can talk about diameter as a line of diameter. You can name it right here, diameter AB, or I could say the diameter of the circle is 3 centimeters, for example. Okay, so the diameter, I could say, hey, the diameter is 3 centimeters. That's, in this case, I'm measuring it. But I could also say, hey, a diameter of this circle C is segment AB. Okay? All right. And let's see one more. Circumference. Whoopsie, sorry. The circumference of a circle is a distance around a circle. That's it. Yay. Pi, the number pi, which is denoted by this Greek symbol, pi, is the value of the ratio given by the circumference to the diameter. And that is pi equals circumference divided by diameter. And the most commonly used approximations for n are, of course, 3.14 or 22/7. The last one here, a semicircle. Let C be a circle with the center O, and let A and B be the endpoints of the diameter. A semicircle is the set containing A, B, and all the points that lie in a given half plane determined by AB diameter that lie on circle C. Okay? That was really confusing. So, in this case, we're looking at a semicircle right here. Okay? So, at all the points that lie on this kind of an arc, it's an arc, and that line segment AB. That is a semicircle. Okay, here would be your center, would be right here. Okay, so well, I hope you enjoyed this learning about the most famous ratio of all, and by now you know it as pi, our friend pi. Okay, good luck on your problem set, your exit ticket, and see you at lesson 17.